Hello everyone, welcome back. This is where we ended on video part 1 on chapter number 3, number play, and this will be video part 2 on number play, chapter number 3, and worksheet number 3, right? So if you did not watch my first video on number play, chapter 3, worksheet number 3, go back to my video part 1. You'll be able to see what I've done. Those who are joining me for now, I said that I'm helping my class 6 students who might have got some challenges. Maybe they lost maybe some students might have lost worksheets. Okay, they don't see any copy. Or some of them might have lost notebooks also. Or some new admissions may be there. Maybe they joined me late after chapter number 1 has been covered. Chapter number 2 also. Maybe they found me doing chapter 3. So they missed chapter 1 and chapter 2. So I think it is best idea to record these videos for all worksheets and then update to the WhatsApp groups of class 6. And then you revise with me step by step, all right? So this is where we ended. Let us now get started. This is the next question, which is talking about Collat's conjecture. Now, Collat's conjecture is very interesting. It is very, very interesting, and it is confusing also. So you need to understand the logic. Okay? So the condition we use, if the number is even, then we take that even number, we divide by 2. Condition number 2, if the number is an odd number, what we do, we take that odd number, multiply by 3, the answer we get, we add 1. These are 2 conditions which Collat's conjecture use. Okay, now let us see. Check if the Collat's conjecture holds for the starting number 50. Meaning, you take this number 50, follow these 2 conditions until this number reduces to 1. 50 has to be reduced by following these 2 conditions until we get 1. This is what we call Collat's conjecture. Now let us start. Starting with the number 50. We're going to follow these 2 conditions step by step and make sure that we don't get confused. Now, starting with 50, you take 50, put it here, and then start reasoning. Is 50 odd or even? 50 is an even number. You need to divide by 2. Get the answer, that is 25. Is 25 even or odd? 25 is odd number. So multiply it by 3. The answer you get, add 1. That gives you 76. Is 76 odd or even? It is even. Divide by 2. This gives you 38. What is this 38? 38 is an even number. You need to divide by 2. What do you get? 38 divided by 2, you get 19. What is this 19? 19 is an odd number. You need to multiply 19 by 3. The answer you get, add 1. You're going to get 58. This 58 is an even number. You need to divide by 2. This will give you 29. 29 is an odd number. Take that odd number 29, multiply by 3, the answer you get, add 1. This gives you 88. 88 is an even number. You need to divide by 2. What do you get? You get 44. 44 is an even number. Divide by 2. What do you get? 44 divided by 2, you get 22. 22 is an even number. Take this 22, which is even number, divide by 2. What do you get? You get 11. 11 is odd number. Multiply by 3. The answer you get, add 1. This gives you 34. 34 is an even number. You need to divide by 2. What do you get? 34 divided by 2 is 17. 17 is an odd number. 17 being an odd number, you need to multiply it by 3. The answer you get, add 1. This will give you 52. 52 is an even number. You need to divide by 2. What do you get? This gives you 26. 26 is an even number. You need to divide by 2. What do you get? 26 divided by 2 is 13. 13 is an odd number. Take 13 into 3. The answer you get, add 1. What do you get? 13 into 3, add 1. That gives you 40. 40 is an even number. Divide by 2. Gives you 20. This 20 is an even number. Divide by 2 also. Keep going. That gives you 10. 10 is an even number. Divide by 2. What do you get? You get 5. Now the 5 you are getting is odd number. Multiply by 3, add 1. What do you get? You end up getting 16. 16 is an even number. Because it is an even number, you need to divide by 2. What do you get? You end up getting 8. This 8 is again an even number. You need to divide by 2. What do you get? You get 4. 4 is an even number. You need to divide by 2. What do you get? 4 divided by 2 gives you 2. 2 is an even number. Divide by 2. Boom. You have 1. Now, since 50, so you say, since 50 reaches 1, therefore, Euler's conjecture holds. Euler's conjecture. Some other people call it rule, because conjecture can be used in place of the word rule. So since 50 reaches 1, therefore Collard's conjecture holds. There we stop. So this is the condition. If the number is an even number, you need to divide by 2. Second condition. If the number is odd, you need to take that odd number, multiply by 3, the answer you get, add 1. And see if that number will reduce to 1. If it does reduce to 1, then Collard's conjecture holds. Next number. Let us see if 38 will reduce to 1. Now, we start the process again. Make sure that you don't rush, because if you rush, any miscalculation will cause conjecture not to hold. So now let us see the next number, which is the number 38. Now let us start. So here, the number 38, and we follow the same rule, the same steps. 38. So here you write, starting with 38. Let us see. 38. What is this 38? 38 is even number, divide by 2. What do you get? 38 divided by 2, you end up getting 19. 19 is odd. You need to multiply by 3, add 1. What do you get? 19 into 3 plus 1, you get 58. What is this 58? 58 is an even number. You need to divide by 2. What do you get? 58 divided by 2, you get 29. 29 is odd. Multiply odd number by 3 and add 1. What do you get? When you do 29 into 3, add 1, you get 88. 88 is even number. You need to divide by 2. What do you get? You get 44. Again, 44 is an even number, divide by 2. What do you get? 44 divided by 2, you get 22. 22 is even, divide by 2. What do you get? 22 divided by 2, that is 11. 11 is an odd number. You need to multiply by 3, add 1. What do you get? 11 into 3 plus 1, you get 34. 34 is even, divide by 2. What do you get? 34 divided by 2 gives you 17. 17 is odd. Multiply by 3, the answer you get, add 1. What do you get? Now, 17 into 3, add 1, you get 52. 52. 52 is even, divide by 2. What do you get? 52 divided by 2, you get 26. Now 26 is even, you need to divide by 2. What do you get? 26 divided by 2, you get 13. 13 is an odd number. You need to multiply 13 by 3. The answer you get, add 1. What do you get? You are getting 40. 40 is even. You need to divide by 2. What do you get? 40 divided by 2, you get 20. 20 is even. Divide by 2. What do you get? You get 10. 10 is even. Divide by 2. You get 5. Keep going. 5 is an odd number. Now, since 5 is an odd number, then take that 5, multiply by 3. The answer you get, add 1. Because this 5 is odd number. Now 5 into 3, add 1, the answer is 16. 16 is even. Divide by 2, you get 8. 8 is even. Divide by 2, you get 4. 4 is even. Divide 4 by 2, you get 2. 2 is even. You need to divide by 2. Boom. You get 1. Now, conclusion. Since, what was the number? The number was 38. Since 38 reaches 1. Therefore, Collat's conjecture or Collat's rule holds. That's all. Alright, so these are the steps of conjecture that is known as Collat's conjecture or Collat's rule. These are the steps which you have to master. If the number is odd, take that odd number, multiply it by 3, and then add 1. If the number is even, divide by 2. Simple. That is Collat's conjecture. The next and the last question on this part. Write 5-digit and 5-digit number to give 3-digit difference. So here, the question says, write 5-digit number and another 5-digit number to give 3-digit difference. Anyway, the instruction is not super correct, but we're going to do it the way how it is. We need to have 5-digit numbers. A 5-digit number, meaning make 5 spaces. In these spaces, there should be 5. 1, 2, 3, 4, 5 spaces. So we have a 5-digit number with another 5-digit number to give a 3-digit difference. Okay, we need to get another 5 spaces. Then, when we find the difference means minus. You have to minus. You must end up getting the answer which has 3 digits. That is what the question is trying to talk about. Write a 5-digit number and another 5-digit number to give a 3-digit difference. It's simple. These numbers, they must be the same. You know, when I'm doing a question, I look for easy alternatives. So this number you keep here and this number you keep here should be the same. So that when you subtract, they end up forming zeros. So you can put any number, but they should be the same. So if here I keep maybe a 4, here should be a 4. So that 4 minus 4 is 0. And also this one can be, say, 9, and this should be 9. So that 9 minus 9, 0. Then you come and play around with these 3 digits. 1, 2, 3, 1, 2, 3. So write 5-digit number, 5-digit to give 3-digit difference. Fine. So here I can put something like maybe 6 here. Yeah. Okay. Then yeah. So 4. 6 minus 4. I'll get 2. Look for either sims. This is 1 maybe. This is 0. 1 minus 0, 1. How about this one? Maybe 7 here. Maybe 5 here. 7 minus 5, 2. Boom. You are done. So this is the answer. So you can see these are the numbers, which is 49,716 minus 49,504. What am I getting? I'm getting 212. This is a 3-digit difference. That's all. You stop here. All right? So bye-bye for now. I'll be back for worksheet number 4, which is on data handling and presentation. So stay tuned. I know you're already tired, but I'm trying to revise with you some concepts, okay? And I think that helps. So I'll be giving you videos together with some notes, which I'm doing here, so that you get a PDF paper, and then you go through it quickly. Fine. But make sure that you watch the video, you understand the concept behind, all right? So I'll be back for worksheet number 4, data handling and presentation. And also I'll be like a quick recap of prime time, which is chapter number 5, prime time. And then I will give you some questions we do together, and then we call it a day. So stay tuned. You'll be revising with me. In case you forgot some concepts, go ahead playing my videos many times, and stay calm, stay strong, healthy, and stay tuned. All right, I'll be back. Bye-bye.